Okay, so hi everyone, I'm Apoorv, and in this talk, I'll be talking about how to build a online code editor. What is basically the system design? I've been figuring out a lot of things. I've been gathering a lot of information. What are the different patterns you can use in the line code editor, and what are the challenges you face while building one? So I'll be talking all about it in this talk. And so, just a small introduction. I am working as a software development intern at Innovisa, and you can connect to me on Twitter at Apoorv_Taneja. And so, let's begin with the content of the talk. So, in this talk, we'll basically see the basics of bundling and compiling code, how to build a basic code editor, how to build a basic code editor, as in just HTML, CSS, and JavaScript, no other frameworks and libraries, and how to compile code in browser, and what are the different security measures which any code editor has to take to prevent malicious attack on their code editors, and how can they make it more secure. So we'll be covering three things in this talk. The first one is whatever the user types will be typing in the code editor will be string. So we have to convert that string into a meaningful code so that our browser, our compiler will understand what is exactly happening. And there will be some piece of code which will be advanced JavaScript syntax. For example, let's say a browser doesn't understand what is promises. So we'll have to look after that thing as well, how to make the browser understand certain patterns, certain things which it cannot understand. And third is the most important point. We have to deal with import statements. So let's say if you write import React from React, so we'll have to make our browser understand what is React and how is it coming. How is it? How will it get the code base of React, and how will it bundle code? So these three are the main challenges we'll be covering in. We'll be seeing different patterns which can be used, and what are the drawbacks and advantages of each pattern, which we can use, which we can consider while building an online code editor. So first, we'll talk about multiple options to transpile code. So as we know, we can't suppose if you write in a code editor const app and return a div. We know that browser won't understand what is exactly happening. We have to transpile our code, right? So there are multiple options to transpile code. The first option is we have a React app, which is basically a online code editor which we are building. We send our code to the backend server. Now the backend server does something and transpiles our code and send back us the transpiled code. So this is the first approach we can use, right? And the second approach we can use is we can use in-browser transpilation. What does that mean is we don't send an external API request. Instead, we just transpile the code in the browser itself. So I can give you a demo what I'm talking about exactly here. So if we, this is babel.js, you might have come across this. And so this is the playground which Babel provides us. So if I write import React from React, so you will see there's no API request which Babel has made to any server. It just transpiled the code import React from React in browser itself. So this is what the second approach I'm talking about. We don't send any API request to the external server. We just transpile the code in the browser itself. So these are the two different approaches we can use while transpiling the code. Now, after transpiling the code, we have to bundle the code. We have to make sure all the import statements are working properly, all the code is bundled, and we are able to get the final output. Now this is the second challenge. Now to figure out the solution for this, we have multiple options. We'll check all the multiple options we have. So the first option is we have a React application, which is a code editor. We send the code to a backend API. That backend API runs Webpack. Webpack finds a missing module. Suppose we have a code like import React from React. So Webpack has a plugin which installs all the npm module which it didn't find, and it fetches all the npm module from an npm registry, stores all the packages which it downloaded into a hard disk, and bundle the code and send back as the bundled code. This is the first approach which can be used to bundle the code. We'll see advantages and disadvantages of each approaches. And the second option is we it's exactly same as approach one, but the only difference we see is in the approach three. Approach which is The only difference we see is in the step three. If we see back, in this we tell Webpack to fetch the modules which are missing and store it in a hard drive and send, and then use them to bundle the code and send back the bundled code. This is the first approach. But in the second one, we are telling Webpack, hey, don't store all the npm modules which you're coming across in a hard disk. Instead, we'll give you a plugin. Instead, we'll give you a plugin. Use that plugin to fetch the code directly from the npm module. Don't download that piece of code. Just use that piece of code, bundle the code, and send back the bundled code. So what we're doing is we are not storing our code anywhere. We are not storing the React code on a hard disk. We are not storing any piece of code. So the difference between approach one and two is, if the number of npm module keeps increasing, our hard disk will get filled soon. We'll have to pay an extra cost for it. But in the second approach, we are not storing the npm modules anywhere. We are just fetching the code and telling Webpack, use this piece of code, bundle it, and send back it to the code editor. So this is the difference between first and second approach. Now we are coming to the third approach. In this approach, we are not using any backend API. What we are telling our code editor is send use in-browser compilation to bundle the code. So there's no API request, there's no server involved with this type of approach. So what happens in this approach is, there's a React app, we have a piece of code, we send it to the browser, and in the browser the Webpack runs, it finds a missing module, it installs, it fetches the list of missing modules, it fetches the piece of code for that particular module, it bundles the code and send back. So the only difference between approach 2, which we saw here, and the approach 3 is just the backend server. In the approach 3, there's no backend server involved at all. So we reduce the cost of API calls here. So the only difference we can see in the approach 1, approach 2, and approach 3 is the number of API calls. We won't be building a different we won't be building an extra backend server for this step, and in this step we'll be doing everything in browser. So now as we saw the now we let's talk about the advantages and disadvantages of approach 2 and approach 3. So in approach 2, basically, which is this, the benefit we'll get is we can cache npm modules. Whatever the request we send to the backend API, we can cache them. So whenever a person requests again, so we can use the cached response to cached response and send it back to the user, and it will be faster on devices which are running on slow internet. So this will be helpful. But the advantages of option 3 is, there's no API involved. We don't have to build a separate infrastructure just for running a backend server, compiling the bundling the code and sending it back to the browser. So this is where we save one of the resources, which is a backend infrastructure, and this will be extremely fast comparison to the API calls. We will be just bundling the code in the browser itself. So there's the time we save is uh, we can save the API time responses. So we'll be using approach 3 throughout this talk, and we'll be seeing what are the challenges we face and how we build we'll build a code editor. So we saw the advantages and disadvantages of transpiling and bundling the code locally, or if we use a backend server, right? So there's just one small problem, that Webpack doesn't run in browser. We have to make a lot of tweaks to make Webpack work in browser. There are a lot of complication involved to make that work inside it. So how will we bundle the code? How will we fetch the import? How will we fetch the npm modules which we have declared in the project itself? So there should be some different approach. So there's a different bundler which is ES build. The other approach we'll be using is ES build. So I'll show you what exactly ES build is. You all might have heard about ES Build. It is extremely fast when it is compared to Webpack and other bundlers out there. As you can see, the response time, which it is showing here, that the time to do production bundle of 10 copies of 3.js library. So ES Build just completed it in 0.37 seconds, and Webpack is taking almost a minute. So we don't want to give a bad user experience to a user will have to keep waiting for the code to get bundled, and then it will be sent back to the code editor, and then it will run the code, and the user will be able to see the output. So we can use ES build here, which is extremely fast, and we can customize it. We can use various plugins to make it more faster and robust, and make it as per our requirements. Now, this is what will be doing now. So initially, what was our approach was, there's a code editor, which will send the code to the Babel. It will transpile it. It will send back to the Webpack. Webpack will bundle it. We'll have the bundled code, and we'll execute it. But now what we are doing is we are removing these two middle steps. We are removing Babel and Webpack. Instead of that, we are integrating ESBuild. So there's no Babel and Webpack involved now. So it's directly like code goes to the ES build. We'll transpile and bundle it there. We'll get the bundled code, and then we'll execute it. So this is how our approach is gonna be now. So how to make use of ES build? So ES build is almost, in when it comes to functionality type, ES build is kind of similar to Webpack. Whenever it will come across an import statement like import React from React, it will start looking in a file systems. It will find, hey, I can't find, hey, I'll look for React in the file system and make use of it to bundle your code. But when we are building online code editor, there's no file system. It's just a browser. The browser doesn't know what is file system. How will it get access to the file system out there? So we have to somehow tell ES build that there's no file system, but you will have to fetch the modules from an other source and use them. So how can we customize ES build for that? So if you see, ES build has a section plugins. There are two we can customize. We have to basically make our own plugin and tell ES build, hey, use this plugin whenever you come across any import request, like import React from React, import React DOM. So use this custom plugin and and resolve our request. So basically, there are two callbacks which we'll be using an ES build, which is resolve callback. So as you see the description, it says a callback added using on resolve will be run on each import path in each module that ES builds. The callback can customize how ES build does path resolution. So what does it mean is, when ES build come across a statement like import React from React, right? So it says this callback will always run when each import path in each module that ES builds. So it will come across the import path, which is import React. It saw that this import statement is there. It will start executing a resolve callback, right? And in this callback, we can customize how ES build does path resolution. So what basically this means is we can tell ES build, don't directly look into the file system for the module which is mentioned in the import statement. Rather than that, we'll provide you a link where you will find the code for the particular module which is imported. That means don't just directly go and look for file system. It will throw an error because browser has no file system. But instead of that, we'll give you a path where you can find the code for the imported module which is mentioned by the user. So this is how resolve callback is useful, right? And next, when we got the path, suppose we got a path that this module, suppose let's say the module is React. So we gave ES build a path. You can find React code there, use that piece of code, and then move further. So after on resolve callback, the ES build goes to the on load callback. We can see on load callback here. Yeah. So what this onload callback does is, as you can see in the description, a callback added using onload will be run on each unique path and names appear that has not been marked as external. So what this basically does is, after every on resolve request, it goes to the on load callback. It will find a unique path. It will say, okay, I know I have to fetch code from this path. It will make a request to that path and get that piece of code from here. And we'll have that particular code, and we can use that piece of code in while bundling. Right. So this is what ES build does is we'll see a pictorial diagram of whatever I explained, how this on resolve and on load callback work. So we can get a good idea what I'm talking about exactly. Okay. So yeah. So, as I mentioned in the on resolve callback, we'll provide ESBuild a path from where it can fetch the npm modules. So if I said import React from React, we have to give that path. We know that there's no file system. So we have to tell ESBuild, you can get this path from npm website. Suppose, let's say this is the a website which we from where we can get the link to any module. So if we do npm view, yeah, so this is the link for React code. If I go to this link in my browser, I downloaded all the React code. So if I open this file and if I go to index.js, I'll see the code. This is what the index.js of React module, the complete React module looks like. Now, I can tell ESBuild, you can fetch all that you can fetch the path which I'll be giving you will be a npm registry link, and you can fetch all the details from there and send this path to onload so that it can download the file. But the problem is, if we try to fetch the code from npm registry website, which is if I do fetch to this, so this is the exact link which we got here, the link which has all the React code. So see, we got an error. It is CORS, cross origin resource sharing. So this means we can't access the npm registry website from any other domain. So this option is not, we can't use npm link to provide the link to the on resolve function. There should be some other way how we can get the npm link or source code for the module which a user has requested. So there's a website which is unpackage. uh, yeah. So this is basically a CDN for all the modules which are present on npm, and we can use this instead of npm registry, because as we saw in the npm registry, it throws a CORS, course origin resource sharing error, which means we can't access it from any other domain. So the only option which we are left with is unpackage. So we can get uh, all the npm packages files from here itself. So if I do unpackage slash react, so I got the same code which we saw here when when I downloaded the index.js file for React.js. This piece of code is same code which we are getting. Just a second. Yeah, this is same piece of code which we are getting from unpackage. So this means we can use unpackage in the onResolve function, and we can tell ESBuild, hey, you can get all the code of React.js if you want from this link. It will give ESBuild will get to know that I have to fetch all the details from the unpackaged link. And on the onload function, it will actually fetch all the details, all the content which is present in the file, and it will be used for bundling. So basically, on resolve will just give the path from where it has to fetch. On load will actually fetch all the path and will give it to the will fetch actually all the content of that file and will give it to the ESBuild for the further process, that is bundling it. Now going back to the issues which we're facing, we already discussed we can use unpackage. So this is basically what the flow looks like. This is a code editor. We send the code in the browser. ESBuild finds an import statement. It sends that import statement to onResolve. OnResolve will find a path that okay, I have to fetch I have, if it's a React module, if it's import React from React, I can get React from unpackage.com, and on load it will actually get the module from the unpackage.com, and it will make a request to unpackage.com. Unpackage will send the React code to it. It will bundle the code, and all the bundled code will be sent back to the code editor. This is what the approach we have discussed so far. So just to repeat, as the code goes to the in browser, ESBuild will start its process. It will start finding an import statement. If it's import React from React, it will see, yes, there's an import statement. I have to fetch the React module. So there's no file system there. So it will go to the onResolve function. OnResolve function will tell that, okay, if there's no file system, I know, but you can get actual code, all the code from this unpackage.com. So it will store this path name in unresolve. This will go to the onload function. Onload function will fetch all the content of that file, and it will send that piece of code to, it will bundle that piece of code and send back the bundled code. So this is what a in browser compilation and transpilation looks like. Now we have the bundled code with us. Now the browser, now we have a piece of code. If it's import React from React and we are using React in a code editor, it will know what this code is. It has properly bundled the code. It knows how to execute each part now. But now the main thing which comes next is, how do we execute it? Where do we show the result? Now we got the bundled code with us, but we have to do something with it. We have to show user what is happening in the code. Suppose the user has a code which says console.log, so we have to actually implement that. We just have a bundled code, we are not executing it anywhere, right? So what are the challenges, what are the next thing which we'll be looking at are how to execute the bundled code which we got from the ESBuild. How to show errors. Suppose a user made some error while bundling, while typing. We have to show that error to the user, that hey, this is some mistake, you have to fix it. So we have to tell the user. And the third thing is, we have to prevent the user from manipulating the actual DOM. So what does this mean is, the online code editor is running inside a browser, right? If you don't want user to make some changes to the browser code, the code editor code itself, right? We just want to give user a separate execution, uh, a separate thing from for executing the code. We don't want the user to manipulate the actual code editor code, right? And the fourth point, which is, we want to prevent users from malicious attack. So all these things, all the things which are mentioned in this slide, the 4 points, can be fixed using iframe. So we'll see how iframe works and how it can help us in solving all the things which I mentioned in this slide. So yeah, so I have a small project which I made there just to demonstrate what is exactly iframe and how can we use it. So basically, I have a iframe tag in it, and the source attribute has a test HTML file. So the file is mentioned here itself, right? So this is a normal HTML document. I have mentioned all the like I mentioned a sample piece of code here. Now we'll see how index.html looks in the browser. So if I, oh yeah, yeah. So this is what the index.html will look like if I run in the browser. So if we see, this is the h1 tag, this is the iframe. If we open this is the code. Yeah, this is the iframe document. This is the iframe tag which I mentioned in this document. Yeah. So basically, we can use iframe to execute our piece of code. So if I make some changes in test.html, so if I add something like, so yeah, I can actually see the changes. The text HTML is embedded in the iframe, and we can see what is exactly happening here. So we can add the HTML document inside our iframe. So what this means is, we can tell iframe the bundled code which we got after ES build bundling and transpiling. We can actually provide that code to iframe. We can tell iframe that you have to execute this piece of code. So basically what we'll do is, after getting all the bundled code, we'll we'll have a sample, we'll have a HTML file. In this HTML file, we can execute all the bundled file, all the bundled code we got. So I can say that in the script tag, I can mention the file which we got, and we can execute this file in the index.html. Now, but talking about the security parameters, if we see, there are two execution frames here. As I mentioned, that we want to prevent user from malicious attacks which can happen. So there is basically a way to fix that. But first we'll see how is iframe, what are the configuration which we'll have to make to prevent that attack. So if we see, if I do something like window dot a equals to 100, so I'm setting a is 100. Now I change my execution frame. I, instead of in the top, I go to the test HTML file, the file which is mentioned in the iframe. As you can see, it is selected. Now I go to this. Now if I do window dot a, it is undefined. I have no access to the variable which were declared in the top JavaScript frame, right? But I can somehow access to the information which I mentioned in the top frame. How I can do is, I can use a parent object, parent dot window dot a. If I do this, I'll be able to access all the information which is present in the main top level execution context. So how can this be harmful? So let's say CodePen. You might have seen people have different CodePens. You have used them. You might have referred some piece of code there. So imagine there's in the JS file, there's a piece of code like axios dot post request https. Let's say this is uh, hackerserver.com, and it sends suppose you have a token. I know no one stores token in local storage. Most of them store in cookies, and there's a different way of storing authentication token. But somehow, yeah, so we do something like, yeah. So what will this piece of code do is, it will send, whenever we are accessing someone's code pen, we are accessing someone's pen. It has the JS, this piece of code in the JS file, and it will send the request to this API, and it will send the token in the body itself, which is really harmful. We can send all our sensitive data which is present in the browser to some malicious server, which is definitely not a good thing. So code editors have to take care of that. So how they can do is, so basically, as we saw that we can access the iframe parent property using parent.window.a. So we can prevent this using a attribute which is sandbox. What sandbox, or the default value of sandbox is allow same origin, but instead of that, if we keep it blank, if we don't provide any parameters inside this, and if we access this, um, let's say if I am on the top frame, yeah, let's say I do window dot c is equals to 200, right? Now I go to the test HTML execution context, and I do win parent dot window dot c. Okay, just a second. I go there. Yeah, so we got uncaught DOM expectation blocked the frame from the original. So we are not allowed to access the parent context, parent execution frame. So what this sandbox property does, it prevents it from accessing all the content with all the sensitive information which is present in the main execution content. So this is how we can prevent our sensitive information. We can prevent the code editors to use the parent execution parent the information is present in the actual browser to send to a different server. So the execution context is different. That execution context is different. That's why it is not able to access parent.window.c. Now this is how basically one of the ways you can secure your text editor. But we'll actually see how the CodePen uses. What is the CodePen approach? So what CodePen does is, whenever user changes the code, it sends the code to an API. It transpiles the code and send back to the code editor itself. But when the code editor receives the transpiled code, what it does is it reloads the iframe. It reloads the complete iframe. What it means is, then it fetches the HTML document from a different API. So the HTML, the file which is mentioned in the iframe, it is fetched from a different API. It says ki I have got the new transpiled code. I need to fetch a new HTML document. It hits that API, fetch the HTML document, and send back. Now the code which we got transpiled code here, it sends back, it fetches the same code again. The code which we got here is just to tell the code editor to fetch a new HTML document. That code is not used anywhere now. After fetching the HTML document, it fetches a new API to send and ask for the same code which we got above here. It sends the same piece of code and it executes here. So what happens in this case is, whenever the iframe is loaded from a different API, the domain is different. The code, it is not able to access the parent property which we saw. So either we can do two things. The one is, either we use sandbox property on a iframe, or we make a request from an API to load an iframe which has different port, different domain, or it's a different type of request. So what happens in the CodePen case is, it is the different API which is transpiling the code, and the API which fetches the content inside iframe is different. So when the API is different, that's a different domain. That's why it is not allowed to access the parent, whatever the content present in the parent object. That is different. That's why CodePen approaches uses this approach by fetching HTML document in the iframe from a different API. And if you don't want to do anything, whatever I spoke about, if you don't want to bundle the code, you don't want to, what we say, use ESBuild, build a custom plugin for it, what you can do is use Skypack. So what CodePen does is, it uses Skypack. So why Skypack is basically a simple solution for fetching all the JavaScript packages. What you just have to do is just import a package from Skypack. Instead of this confetti, you can do React, and you can start using React inside it. So this Skypack provides you the browser ready, browser usable piece of code, and you don't have to do anything. So CodePen works on this Skypack. If you go to Skypack website, you just import the code from Skypack CDN server, which is import React from HTTPS CDN Skypack React, and that is the executable browser ready code, and you can use it anywhere, and you don't have to do all the things which I spoke about. So this is how a CodePen works. So we can check. You can definitely check Skypack for. If you're building on an online code editor, you don't have to deal with all the bundling and compiling code. It will automatically provide you with the browser ready code. So this is how you can actually uh, compile the code in browser. You can get all the bundled code and execute it in the iframe and prevent the other users from malicious attack. So all the content is the references I've used is, there's a course by Stephen Grider, which is basically where he builds an online code editor. I have referred CodeSandBox Engineering blog. CodeSandbox basically use the approach, the backend server approach. They send the code to the backend, and then it sends the bundled code. CodePen Engineering blog, I also checked it. They use Skypack for bundling code. So I'm currently building an online code editor, and I'm referring different sources out there. So these three top sources helped me a lot, and in building a code editor, and I'm still building it. So you can refer to these three sources and can learn a lot about them. So that's all for